out, I will ask you just to kindly put those away, and headphones as well. Okay, so we'll change this to 3. All right, Karen, you ready? Why is that funny? Okay. Okay.
I'm ready now.
Shh. Great. Okay. So we're going to move forward with some of the exponent stuff. If you want some extra practice, I do have some extra questions with this stuff, so you can let me know later. So we're going to move on to what we call rational expressions. So yesterday we worked with exponents and rational exponents. Now we're going to work with rational expressions. What did we say the word rational means yesterday? Fraction. Good. Okay. So we are working with expressions within fractions. So today we're just going to talk about how we can simplify and multiply them, and then we'll do some division and then addition and subtraction as well. Okay, so the first thing that we need to know when we're working with rational expressions is something called restrictions. And you guys will remember on the first day when we were doing a review, we talked about how you can't have a denominator of 0. Okay? Somebody remind me why we can't have a denominator of 0. Why can't I have something over 0?
Because you can't divide something into 0 groups.
Oh yeah. Okay, I can't divide something into 0 groups. That doesn't make sense. So if I do 6 divided by 2, I'm dividing 6 into 2 equal groups. But if I do 6 divided by 0, how do I divide 6 into 0 equal groups? That doesn't make sense, right? So we can't have a denominator of 0. So restrictions are basically looking at what's in the denominator and making sure that I don't have an expression here that could potentially be 0. So I need to restrict this x value so that no matter what I plug in here, I don't end up with 0. So what would make x minus 2 equal to 0? What would I have to plug in for x? 2. Okay, so in this case, x cannot equal 2. It can be anything else, but it can't be 2 because if I sub in 2, I'm going to get 4 over 0, and I don't want to have 4 over 0. Okay, that's undefined. We can't do that. Okay, so that's kind of the act. I don't need to restrict the numerator. It's okay to have 0 in the numerator. So we're just looking at that expression or expressions in the bottom and seeing what we need to restrict. Okay, so no denominators of 0. Sorry. Actually, let's just do this. Yeah. You got it. Okay. So let's try to write some restrictions here. Okay, this one, because I have 2 expressions here that are being multiplied, I'm going to have 2.
No, positive 3 and negative 4.
Okay, so x cannot be 3, and we usually just put comma 4. So if there's multiple values that x cannot be, we'll just write it in a list like that. Okay, so these are my restrictions for this expression. Remember, only the denominator, the numerator is okay. Okay, next one, I think we can do this part really easily. Any ideas on that one?
3. Not negative.
X cannot be negative 3. And what about this, when I have a single x like that?
1.
No.
2.
What makes that thing equal to 0? 0, yeah. So x cannot be 0. If it were 1, I would have to have an expression that looks like x minus 1, right? So when I just have a single x out front like that, 0 makes that whole denominator 0, right? Because then I'll have 0 times 3, and that makes the denominator 0. Okay, and then sometimes we may have to factor the expression in order to see the zeros. So yeah, we could try to sub in a bunch of x's into our denominator for part C and try to figure out what makes it equal to 0. We might miss one. So the best course of action here is just to factor this guy. So what two things multiply to negative 18 and add to 3? Sebastian? 6 and negative 3, perfect. So this is when a equals 1, so we can just sub them right into the brackets. Okay, so we need to make sure that we have our factoring down pat for this guy, because I'm going to be expecting you guys to be able to do this pretty quickly. Okay, and then here's my two expressions, so I should have two restrictions. Negative 6 and 3, perfect. Okay, so that's kind of our first part. We want to make sure no denominators. Claire, can you just grab that back door there? It's just a little bit loud. Thanks. No denominators equal to 0, can't divide by 0. So anytime we have variables in a denominator, we have to restrict them. Okay, so no matter what, if there's a variable down there, it needs to be restricted. Okay, all right, canceling. So we're going to simplify and state restrictions here. So the simplifying stuff, this should be pretty straightforward given that you guys have done work like this, right? So when I have multiple different variables in the denominator like this, I want to restrict both of them. And although I may be able to cancel out, I still do need to restrict anything that was once in a denominator. Sorry, my pen's just not working here. No, there we go. Okay, so before you cancel anything, you need to look at your denominator and you need to restrict. So if I have something times something, if one of them is 0, it makes the whole thing 0, right? So I need to make sure that x does not equal 0 here, and I also need to make sure that y does not equal 0. That will cause the whole denominator to be 0. Okay, so those are my restrictions. And then, is there anything that I can simplify further here?
The x2.
Right, so I have x squared divided by x, so I would just be left with an x on top. Okay, so 2 x's on top, 1 x on bottom, we cancel 1 from each, we're left with 1 on top. Okay, so that's our final simplified form, and this is also part of our answer as well, right? So those are our restrictions. Okay, so again, before I simplify anything here, I want to restrict. So what's the variable in the denominator? It's x, so I need to restrict that x value. So I have 3 times x and 2 times x. What x value or values will need to be restricted so that I don't get 0 on the bottom?
Negative 3?
So is 3 times negative 3 equal to 0?
0.
Ah, okay, x cannot be 0.
That's what I meant.
Anything for this? 2x?
0.
That one's also 0, right? So we took care of that with the first one. Perfect. Okay, so starting with the numbers here, I'm just going to do some canceling out. So you can, because we have multiplication here, and it's just individual fractions, I can actually cancel out any numerator value with any denominator value. So I might just start by reducing this 2 and 4 here. And then we can also reduce the 3 and 12 to 1 and 4. Okay, maybe we'll just take a second and write what we have. 2 times 4 is 8. X squared, x cubed, over 1 times 1, so x times x. Now I like to just do kind of like a balancing thing.
Are we
Okay.
just simplifying for that?
Yep, we're just simplifying, yep.
Okay.
Okay, how many x's are on top? How many x's are on bottom? So we can cancel out 2 from each. So what would be left after we do that? If I have 5 on top and 2 on bottom, and I cancel out 2 from each, I have 3 left on top. So really, I just am left with 8x cubed. Or if you like to like cross things out or whatever, I have 2 x's down here that can be reduced with this x squared, and then I'm left with x cubed, right?
When you add all of it together, like how do you get 8?
I multiplied 2 and 4.
So would it not be x5 on the top, and it's x2 and x3?
It is. So I have 5 x's on top, and then I have 2 on the bottom. So I cancel out 2 from each, and I'm left with the 3 on top.
Okay.
Okay, if you would like, you can always just simplify on top and bottom, and then you can reduce from there if it confuses you to just like balance like that. Okay, good. So our job is to simplify and state restrictions. Anytime you're doing any kind of like multiplication or division or addition or subtraction type question, what we always like to do is just factor every numerator and denominator as much as possible. So maybe that looks like common factoring if you have more than one term, or it might be trinomial factoring like we did earlier. But we want to fully factor everything so that we can easily see the restrictions. Okay, so the first thing that I'm always going to do is factor or common factor. My pen's not working again, so oh, there we go. So always factor or common factor first. All numerators and not all denominators, okay? If I just have a single term, I can't do anything with that. But if I have multiple terms, then I will common factor if possible or do other types of factoring. Okay, so in this top left numerator, I can common factor an a, not cancel, sorry. And I would be left with a plus 2 in my brackets. And I can't really do anything with the bottom left denominator or the top right numerator because they're single terms. And then in this guy here, I'm going to common factor. I think I can take out a 5 from both of these and 1a from both of them. So I'll take out 5a, and I'll be left with a plus 2. Okay? Next, before I start canceling anything, I'm always going to restrict the variable. Okay? So write your restrictions. Okay, so maybe we can just write them right underneath here. So this one, the variable's a, so we'll have restrictions on a. So a cannot equal
0.
0 is one of them, yes. That's produced from these two guys right here. And negative 2, good, that's from this. Lovely. Okay, and then once everything's in fully factored form and you've restricted the variables in the denominators there, you can start canceling. Now here's the idea with canceling. So we talked about how if you go to cancel something and there's an addition or a subtraction sign right next to it, you can't cancel it. But once we have something factored, I can actually cancel out like a full grouping of like an addition of two terms with its exact same group. So do you guys see how we have the like a plus 2 and the exact same group over here? As long as this operation is multiplication that's happening here, I can actually cancel. So when I have multiplication, remember we talked about we can cancel any top with any bottom. So the first thing that I can cancel here is I can cancel a full grouping of a plus 2 and a plus 2. Those cancel each other out. I can also cancel this a and this a. And I can also cancel 1a out from each of these on the right-hand side here. So 1a there, and then I'll just be left with 1a there. This is the fun part. And then I can just reduce the 5 and the 20 to 4 and 1. Okay, if this confuses you, like if you're not sure what's left, you can always do it in a couple steps, like rewrite, but just make sure you don't miss anything. So on the top here, I now just have left a 4a, and I have 3 times 1, so I just have 3 here. Okay, so the last step here is just to start canceling. Pardon?
How do we know restrictions?
Restrictions we get from the denominators here after we've factored. So this one and this produce the 0, and this produce the negative 2.
How did the 1 produce the 0?
Because it's like a multiplication.
3 times 0 equals 0. So we want to just restrict anything that makes the denominator 0. Does that make sense?
Yeah.
Okay. Good. Any other questions for this guy? Carlo?
dA squared, how did you get rid of the exponent 2?
So I canceled out 1a from each of these right here. So if you look at the blue, so I had 2 and 1, and then I canceled out 1 from each. Okay, good. Okay, let's try another one. So factor or common factor as much as we can. I think these ones, because they're only 2 terms, we can really only common factor. So I can take out a 4 from the top here. I can take out an x in this denominator. I'll be left with x plus 8. And I think we have a common factor of 3 in the second denominator here. We can't forget to restrict before we start canceling. So restrictions on my x's. Raise your hand, just so everybody has a chance to think about it. Daniel? Okay, x cannot be negative 8. That's because of this. Ivana?
-6.
-6. And Carlo, give me the last one.
On the outside, I think it would be 0.
0, you're right, yeah. So -6 comes from this guy, and then 0 is coming from the single x out here, right? Because if that's 0, then it's 0 times 8, and you'll get 0 for that whole bottom. Good. Okay, once we have our restrictions done, we can start canceling, okay? So any top with any bottom. Remember, you have to cancel out full groups if you have additions, right? So I can't cancel out an individual. I'm just going to point to this so everyone can see. You can't cancel out an individual x here with an x here, okay? Because I have an x plus 6. So remember we said if you're canceling something and you look next to it and it has an addition or subtraction, you have to stop, okay? But if I have another full group of x plus 6, I can cancel that out, like the whole group, okay? So you guys see how we have a full group of x plus 6 here? I cancel it out with that full group of x plus 6.
Will they often have that? Like 2?
Sometimes, yeah.
Okay.
Okay. What else do you guys see that can be reduced here? Elise?
The 12x squared and then the x outside the bracket.
Okay, so there's an x outside of a bracket here. Can we reduce 1 out of each of those? So that will be gone, and this will be just 1x left. What else, Isabella?
You could switch the 12 and reduce it to a 4, and then this would be 1.
Perfect. So the 12 and the 3, we will reduce to 1 and 4. Anything else? Okay, so if it helps, you can just rewrite what's left in each bracket or in each part, and then we're just multiplying across here. Okay, so multiply numerators, multiply denominators. So we're left with 16x over x plus 8. Now, can I reduce any further here?
Yes.
Yes?
16.
With 8?
Yes.
So remember what we talked about. If you're canceling something or reducing something and there's a plus right next to it, can we do that? No, we can't, right? So, and I can't do it with the x's either, right? Because there's a plus here. So that's actually as far as we can go with this guy.
What if it's like you get like subtraction on the bottom? Would that happen? Like if it's not necessarily plus, but you still wouldn't be able to like.
Yeah, so if you have a plus or minus sign in between your terms, you don't want to cancel the individual terms there
Okay.
or reduce them.
Wait, so why do you cancel the exponent on the...
So I canceled out 1x here with one of the x's here. So I was just left with 1x. Anything else? Okay. All right, so this one's just asking us to simplify and state restrictions. So first things first, we always factor and common factor as much as possible. So I'm looking for two things that multiply to 2 and add to 3. 2 and 1, good. Okay, we restrict before we cancel. So x cannot be, I think these ones are easy to see, -1 and -2. And then I like to sometimes just throw some brackets around here just so that I remember that I have to cancel out a full grouping if I have terms that are being added, right? So I can actually cancel out this full group of x plus 1 with this bottom full group of x plus 1. So I can do that. What would be left on top? 1, yeah. So it's 1 over x plus 2.
And you have to take the brackets off x plus 2, right?
I mean, you don't have to, but because it's not being multiplied by anything or anything like that, we usually just drop them.
Okay.
Questions so far? Any questions on this guy? Okay, so factor, common factor first, always. Does anybody recognize the pattern in the numerator here? Owen? Julie? Ooh, close. Yeah, there you go. So how do we factor difference of squares?
Square root of the first or b and c value.
Okay, good. So square root of the first and the second. And then I'm going to have basically the same bracket, but one of them will have a plus and one of them will have a minus. So the square root of the first goes in the first slot, and the square root of the last part goes in the last slot, which is 3, not 9. 3 and 3. Okay, now I want to common factor this guy on the bottom, so I'm looking for two things that multiply to 12 and add to 7. Thank you. You said that so excitedly. 4 and 3. Okay, so we factored. We want to restrict. Close.
-3.
Yeah, -3 and -4. Good, yep. Okay, and now I can cancel full groupings, right? So what are the full groups that you guys see that are similar here? Yeah. Yeah, so we can cancel those guys, and then we're just left with x minus 3 over x plus 4. Elise? So remember, only the denominator can't be 0. It's okay if the numerator is 0.
And then you can't simplify it anymore because it's x plus 4.
Right. So we don't want to cancel these x's or anything like that because they're right next to additions and subtractions.
Okay.
Good. Can I scroll? Okay. We're going to do a couple tougher ones, and then you guys are going to do some practice on your own. Okay, so first things first, we are going to factor and common factor as much as possible. Okay, so I don't think there's anything that we can do to anything other than the bottom right denominator. I can find two things that multiply to 3 and add to 4. 3 and 1. Okay guys, we're almost done, just focus in here. I usually like to just throw brackets around this guy too, just so I remember that I have to cancel that full grouping, right? So whenever I see something like that, I'll probably just like throw a set of brackets around, and then by the end, if I don't cancel it with anything, then I'll just drop the brackets later. So we're going to restrict before we start canceling anything.
0.
Good. X cannot be 0. -3 and -1. Awesome. Okay. Now the fun part, right? Because we could We get to just cross things out. So what can I cross out?
X plus 1.
X plus 1.
Okay, full grouping of x plus 1 with this full grouping of x plus 1.
Can we do just the x's?
Yep, I can cancel out the x's here, so that's gone and that's gone. Anything else?
No.
Okay, so what's left? Well, on the top we have 3, and on the bottom we have 2 times x plus 3. Okay, notice that in this case I actually left the brackets on that x plus 3 because it's 2 times that whole thing. So it's actually important that we maintain those brackets. And it's not necessary for me to bring that 2 in because factored form is simplest form. So I'm actually just going to leave it in factored form. Carla?
So when it comes to restrictions, what's the actual like mathematical point of like stating them? Is there like a specific?
Those are like undefined areas. So like if we think about this as like a graph of a relation or a function, these are actually undefined areas of that function or relation.
Oh, okay.
Yeah, that's a good question. We'll talk a little bit more about that in some of the days to come too.
Okay.
Okay, one more. Any questions on this before we move forward?
It's actually pretty easy.
Good. Okay, so factor and common factor everything. So I think we can trinomial factor both on the left fraction here. So 2 things that multiply to negative 15 and add to 2.
X plus 5, x minus 3.
Good. Positive 5, negative 3. 2 things that multiply to 18 and add to negative 9.
Negative 6 and negative.
Okay. And again, like I said, I like to just throw brackets around these binomial expressions here, just so I remember not to cancel individual parts of those. Okay, don't go canceling happy yet. We need to do restrictions. Okay, so I think these ones are pretty easy to see. We can't have 6, 3, or negative 5 as x values in this function because they would cause our denominator to be 0. And this one's actually such a fun one because this cancels with this, and then this and this cancel, and this and this cancel. Okay, so can I ask you, essentially what we just did is we divided something by itself, right? So I had the same thing on top that I had on bottom. So what's left?
0.
No.
1 over 1.
1, yes, good, thank you. Like when we divide anything by itself, it's 1, right? Good.